All right, I just want to do this exercise because it's a good one, and I think it'll help a lot of students. So these really should be like numbered 1, 2, and 3 because they're 3 separate problems. They don't have anything, like they don't relate to one another. So here we're looking at the graph of f, and it says determine where f is concave up and where it is concave down. So if you're looking at the graph of f, concave down would just be when any tangent line you draw has the graph lying below it, and concave up will be any tangent line you draw has the graph lying above it, and then the changes are at these inflection points. So I'm gonna color code it here. So like concave down would be what I'm hitting in green here, right, all the way till about there, and then here that would be concave down, and then concave up would be here. So we're gonna say concave down, okay, on the interval negative infinity to -4, and then from 5 to infinity, and concave up from 1 to 5. Okay, so then note, obviously these are inflection points. It's kind of rarely the case, like you're going to be looking at the graph of f to do this stuff. More likely it's like this level or the one below. So now, notice it's the same graph, but I'm saying like now, this is f prime. What you're looking at now is not the function itself, but its derivative. And we still want to answer the question, when is f concave up and when is it concave down? Well, now you have to understand that a function's concave up when its derivative is increasing. So this means f prime is increasing. And concave down is when f prime is decreasing. So notice that changes how we look at this graph. Now, what colors did I use again? I used green for concave down. So concave up now is this section, because that's f prime and it's increasing, and then also here, and then concave down is when f prime is decreasing. Because again, look, we're looking at f prime, right? That's what we're looking at. So f prime decreasing, f prime increasing, so therefore concave, concave down would be on the interval -1 to 4, and then from 6 to infinity, and concave up from -infinity to -1, and then from 4 to 6. Okay, so again, at this level, that's how you look at a graph. And notice what that means. It means that inflection points, right? These are inflection points right here. Now, I'm not saying these are inflection points for the graph we're looking at. What I'm saying is that these are inflection points. These are the locations of inflection points for the function f we cannot see. And then the third level down, like let's pretend now we're looking at f double prime. If that's the case, then concave up is just when the second derivative, then the second derivative is positive. Okay, and concave down is when the second derivative is negative. And so this time, we're simply looking when the graph is above or below the x-axis. So all of this means your graph f, right? F is like 2 levels above, right? We're at its second derivative. This is where f double prime is positive. And these sections, it's where it's negative. Okay, so concave down would be -infinity to -4, and then from 8 to infinity. And concave up would be -4 to 8. And so I find students like this exercise because it kind of puts it's the same graph, but we're calling it different things. And so notice we look for different things. Oh, so I guess also now that's an inflection. Well, this is the location of an inflection point for the graph of f, again, which we can't see, as is this. Okay, because that's where concavity is changing. In any case, that hopefully that's helpful. It's kind of a nice way of doing it, I think.